the slope-intercept form. So with this slope-intercept form, there is a formula that we're going to be working with, and some of you have maybe heard of this before, but what it's called is the y equals mx plus b. And y equals mx plus b is what we call the slope-intercept form. So what it starts with here is, if a line has slope m and the y-intercept is b, then the line is described by an equation of y equals mx plus b, the equation that I was just talking to you about. Remember, slope, that's going to represent my m. So my m is my slope. Remember, slope is rise over run. And the y-intercept b, this is where, b is here, the y-intercept. This is where, when you have a linear line, the y-intercept b is where the line crosses the y-axis when it's graphed. And I'm going to show you some examples here in a little bit. Any linear equation can be written in slope-intercept form, which is the form of y equals mx plus b, by solving for y and simplifying. So we're going to get into some examples here. So for these examples, for this first set of examples, they want us to write the equation that describes each line in the slope-intercept form. So what we're going to do here with A, B, and C is we're going to take with what's given to us, and we're going to put this in the slope-intercept form, in the form of y equals mx plus b. So for A, what I have here, they're giving me my slope is negative 12, and my y-intercept is negative half. Remember, with the slope-intercept form, m represents your slope, and your b represents your y-intercept. So let's write this in the form y equals mx plus b. So we have y equals, my m is my slope here is negative 12, x plus my b, which is my y-intercept, so plus my negative 1/2. So we've written in my slope, we've written in the y-intercept, so this is my final answer. Y equals negative 12x plus negative half. The next one, we have a slope of 1 and a y-intercept of 0. So we are going to write y equals, my slope is 1, so 1 times x plus my y-intercept is 0. So we can write it like that, but we can actually simplify this because plus 0 just is nothing. So we can actually write this as y equals 1x or y equals x. So this would be the final answer simplified down, given my slope, given my y-intercept, putting it in the slope-intercept form and simplifying it. Let's look at C. C is a little bit different than A and B. Here they're giving me my slope, which is 8, but they're giving me points that fall on a line at negative 3, 1. They're giving me an x point value and a y, but they're not giving me my y-intercept, my b. So let's set this up in the slope-intercept form. We can set this up in the y equals mx plus b form. And what you'll notice is we're actually going to be solving for b. We are given my y with the ordered pair points. My y is 1 equals m, my slope is 8, times my x. My x is my ordered pair, negative 3, plus my b, my y-intercept. We don't know my b, that's what we're figuring out. Now let's solve using orders of operation and solving for equations to find b. 8 times negative 3 is going to give me negative 24, so I have 1 equals negative 24 plus b. I will add 24 to the left and to the right side. So what I'm left with for my final answer here is b equals 1 plus 24 is going to give me 25. So my slope-intercept is b equals 25. I'm not done with this answer yet though, because now we can write this in the slope-intercept form. So the slope-intercept form of this is going to be y equals my slope, m, 8, x, plus my b, 25. So there's really two answers to see here. We're finding my slope, I'm sorry, not my slope, my y-intercept, which is 25, and then writing out my final answer in the slope-intercept form, which will be y equals 8x plus 25. Our next set of example problems, they want us to write each equation in the slope-intercept form if it's not in the slope-intercept form, and then they want us to graph this on the line. So here we have for A, y equals 2/3 x. So we need to make sure these equations are in the form of y equals mx plus b. M is my slope. B is my y-intercept. Now, I don't know if you remember from the first slide, but I mentioned the y-intercept, your B, is where your linear line is going to cross the y-axis. You have your x-axis going left and right. You have your y-axis going up and down. And then once you have a point on the y-axis, you can then graph your slope based on rise over run. So looking at A, is it in the form of y equals mx plus b? It is. So we don't have to put this in the slope-intercept form. It's already in that form. Notice they're not giving me a b. They're not giving me anything. So we can just think that's plus 0. So how can we graph this equation based on what's given to us? Well, remember I mentioned my slope is with x, my rise over run, so 2/3 is representing my slope. I'm not given a b, a y-intercept, so when you're not given a y-intercept b, you always start at the origin 0, 0. And so when we start at 0, now we can graph using our slope. We're going to rise 2, so from 0 we will rise 2, 1, 2, and run to the right 3. 1, 2, 3, and I will put a point here. I will put a point there where it falls at 3, 2. That's where my second point will fall. I can graph another point on this coordinate grid based on my formula here, on my equation. If from my second point I rise 2, my slope rise 2, run 3, 1, 2, 3, I put a third point. Notice how these points are all lining up in a linear line. I can even put a fourth point. From my third point I rise 2, I go to the right 3, 1, 2, 3, and I put my fourth point. Oops. So now once I'm done graphing points on the grid, on the graph, I can connect them with the straight line. Please use straight line. I know mine's not perfect with using my stylus here. You will need to use a ruler on your bookwork problems and any quiz or test where you're graphing. And notice this creates a straight linear line. So working with the slope-intercept form, this will always create a straight linear line for you. Let's go on to B. We have 6x plus 2y equals 10. This is not in the slope-intercept form, so we need to put this in the slope-intercept form. So what I'm first going to do is I need to get this 6x over to the right side, so I'll subtract 6x to each side. So what I have now is 2y equals a negative 6x plus 10. I'm starting to somewhat put this in the slope-intercept form, But notice that I have a 2 connected with my y. We need to get y all by itself. So what I'm going to do is divide 2 to the left side, divide 2 to the right side. When I divide 2 to the right side, I'm dividing 2 to the 6 and to the 10. So what I'm left with here is y equals negative 6 divided by 2 is going to give me negative 3x plus 10 divided by 2 is going to give me 5. So this is my final answer in the slope-intercept form. So now once we have this in the slope-intercept form, we can graph it. Notice I'm given a y-intercept here. My y-intercept, my b, is 5. And my slope here is negative 3. Notice my slope is negative. So how can I start graphing this line based on the equation on my coordinate grid? Well, I first look at my y-intercept, my 5. This is where my linear line is going to cross the y-axis. So I look along the y-axis. I start at the origin 0, 0. I go up to my y, 5. Go up to 5, which is on the y-axis. 1, 2, 3, 4, 5, and I'm going to put a point. That's my starting point. From my starting point, from my b, my y-intercept, I now can put additional points based on my slope. So notice my slope is negative 3, so we can think of this as negative 3 over 1. Oops. So from my y-intercept 5, I'm from there going to rise negative 3, which means going down 3. 1, 2, 3, and I'm going to go to the right 1, and I'll put my second point. From my second point, I can keep going down 3, 1, 2, 3. Notice I'm going down because it's negative 3 to the right 1, and I'll put my third point. Oops. I can put an additional point from my third by going down 3, 1, 2, 3 to the right 1. And you can graph as many points as you want on this grid as long as they're falling on the coordinate plane. And then once you're done graphing them, what you can do is you can connect those points to draw a straight linear graph. Notice the first A, this is a positive slope. Which makes sense because my slope is positive. Notice my second one, B, is a negative slope. Which makes sense too because my slope here is a negative 3. Looking at C, we have y equals negative 4. So this is in the form of y equals mx plus b, the slope-intercept form. But notice they're only giving me negative 4. They're only giving me my y-intercept here, really, because they're not giving me a slope or anything like that. So what I can do is I can just graph y equals negative 4 by going onto my graph, starting at the origin 0, 0, going down 4, 1, 2, 3, 4 from the origin 0, 0. I'll put my point. When you have y equals a value, this is going to be a horizontal line. So I can draw a straight horizontal line, whoops, going through the point negative 4 along the y-axis. Oops, I'm sorry, that's not the straightest line here. Let me make it a little bit neater for you. It looks like it's not letting me erase. Oh, there we go. That's a little bit better, not perfect. But I think you get the idea. When you get y equals a value, it's just a horizontal line. You graph it, and this is this would be considered a horizontal line with just given y. Our last example here, we are given a graph. It says a closet organizer charges $100 for an initial consultation fee plus $30 an hour. The cost as a function of the number of hours worked is graphed below. So here we have the organizer's fee, with the time for my x-axis and the total cost going along my y-axis.